Hello, my friend. Welcome to TVU channel. 2021 has ended. In this year, I have made a lot of projects and designed a lot of motors. They all have unique ideas that I have not seen before. Every week, getting original ideas, designing new motors, and uploading a video is really a hard job for me. Now, I will share with you the ideas and concepts that may inspire you. Keep watching. Let's start. Number 10. DIY flexible shaft with 3D printer and steel wire. In 2020, I have made the longest 3D printed flexible shaft in the world. At that time, I had just started learning how to design a 3D motor. I have little knowledge about the mechanical and engineering field. Even the idea and the concept are correct, the amateur motoring method makes the construction difficult and complex. The new version I designed has changed this situation. I use some cheap commercial goods to make it. It is cheap, easy, and practical. Using a Teflon tube with a stainless steel wire, you can make it as long as you wish. If you change the ball bearing to a new type, it will be more stable. Number 9. Stacked N20 gear motor. Recently, I'm interested in the N20 gear motors. They are series motors in fact. The N20 motor connects to a whole metal gearbox that changes the output speed. By decreasing the speed, the output torque is increased. The normal N20 motor has about 0.4 mN/meter or 4 gram/centimeter stored torque. By decreasing the speed 250 times, the torque can increase 250 times, that is about 1 kg/centimeter or 100 mN/meter. Someone uses the parallel motor connection that increased the torque, but I have not seen others using the series motor connection, especially the series gear motor connection. I have made the world's first time stacked N20 gear motor together experiment. I expected that the output speed will increase without decreasing the torque. Unfortunately, the result is not as I expected. The speed increased as I expected, but the torque decreased. I didn't know what happened at that time. What is the additional power of the second gear motor that goes on? Now I know it may be caused that when connected as serial configuration when rotating, the second gear motor works as a power generator. They will generate the power against the first gear motor. It means that half of the additional power is wasted on keeping the second gear motor rotate at the same speed. I designed a new construction that connects the gear motor as a parallel configuration. I designed a small gear that connected to the N20 gear motor. The outer gear has 4 times teeth as the small gear. Use a ball bearing to fix the outer ring as an outboard shaft. It is very easy to connect them all together. It is really powerful for this small N20 gear motor. This specification cannot be directly brought with N20 type gear motor. You should use another large gear motor such as this type. We can see the cost increased a lot when the torque increased. Use the parallel stacked N20 gear motor. We can use a small motor to get a very powerful output torque. Number 8. Homemade all-metal N20 gear motor. Since the N20 gear motor is very useful, I have tried to make them all myself using cheap commercial goods. I DIY a N20 gear motor using the gearbox, very small gear, and a powerful hexapole rotor motor.
They use a patented technology that provides 2 times torque compared to a flat or round motor of the same volume. Also manufactured in very high precision condition, but still not so expensive. The homemade gearbox is not as good as I expected. From the hexapole rotor motor specification, I expect a much higher torque. I only get about 1/5 of the theoretical results. The reasons may be as listed below. I use a 0.2mm module gear to fit the gearbox, since I can't find the 0.15mm module gear. Also, the handmade position is not fitting the gearbox very well, and the square motor can be used at higher voltage condition. If we solve all these, the output torques should be improved as well.
Then I designed a new version that used the gearbox gear itself. Since the gear module is completely fit, the final whole metal geared motor works very well. It is better than the commercial one at the same specification. At the maximum condition, 9 volt, the torque can reach as 2 times the commercial one, almost reach the theoretical results. The total cost is less than half of the Amazon 60 RPM geared motor, but the performance is double. I have made a homemade gearbox, very powerful and cheap. After that, using the same idea and concept, I have designed the stacked geared motor with parallel configuration. It works very well. In theoretical, it can provide a very powerful torque. It can be used in daily life at a very low cost. Number 7. 2D printing using G-code and 3D printer. Change the 3D printer to a 2D plotter or handwriting machine is not a new topic. There are a lot of videos explained how to do it. After I watched the video, I think there are still some issues that must be considered. Most of them use a ball pen as a writing tool, but with hard contact with the 3D printer bed. It is hard to adjust the height of the ball pen, or it will harm the bed or not contact with the bed. Another issue is they usually remove the hot end when used as a 2D writing tool. It is also not convenient, since I don't want to disconnect the hot hand at any time. I designed a simple case to fix the ball pen to 3D printer head. This ball pen was used for writing, and it is very smooth and handy. I use a spring to connect it to a ball pen shell. The ball pen can move up and down a little straight. Fix the ball pen to 3D printer head is also easy. You can adjust the strength by adjusting the ball pen shell position. It is easy to fix and can contact to 3D printer bed softly and firmly. After finishing the hardware construction, I had explained the G-code in detail. I had also made a special video that explained how to change DXF or another file format to G-code. Following the workflow, you can change them to G-code that fit your 3D printer easily. Then I designed an independent cover that fits my Anycubic i3 Mega 3D printer. It is very strong since several screws are used to fix the cover. It is like an exoskeleton of the 3D printer. It is easy to use and does not interfere with the original 3D printer function. Using these ideas and concepts, you can also make a similar version to fit your 3D printer easily. There, I have designed a multi-pane plotter to test the performance of this exoskeleton. This is the cross-section figure of the design. The pane can only move up and down along with the Z-axis. It is very smooth and precise in precision. If we adjust the diameter of this hole to optimize the size, the error can be limited to less than 0.1 mm, I think. Outside the holder, I use a clip and 2 screws to fix the holder. It is very easy to use and stable. Let's see how it works. It works very well. Then I tried using a multi-pane plotter to draw a multicolor picture. I have made a special video that explained how to do the job. Following the workflow, you can also make color printing easily. And I have made several videos that are using Excel and mathematical equations to generate the G-code file. You can get numerous beautiful figures automatically for 3D printing easily. Number 6. Directly 3D print vase using Excel and equation. I have modified my 3D printer to be a 2D plotter. I printed some beautiful figures using some mathematical equation. With the help of Excel, I can simply generate the G-code file and print them. For 2D plot figure, I must know the initial height of the pen. For 3D printing, there is no need for this step, but you must know the filament extruding length. Using a simple 3D model and slicing software, we can calculate the distance between these 2 points, and the extruding factor as well. Finally, we get the extruding factor average value. Add the Z-axis control command and other parameters such as field density. We can directly 3D print the beautiful teapot board. We can see the pattern is very beautiful and natural. After these tries, I want to control the Z-axis more. The printed vase shape is calculated using Excel, and the Z-axis is also simulated using a mathematical equation. By using Excel and a VBA application, we can generate the G-code directly with the Z-axis control. With the combination of Fusion 360 that generates the vase base, we can directly 3D print a beautiful vase. And as usual, I make some advanced modification. The image that every 3D printed layer is the same. Only the size of the image will change depending on another equation that defines the side shape of the vase. You can also change other parameters here, such as height, step height, vase size, etc. Now, if we rotate the image in the angle defined here in the definite height, every 3D printed layer will change the definite angle. Every X, Y position that rotates the image can be calculated using these equations. Combine the vase base and the Excel output data together. Add the ending part as well. Take care that the final height should be higher than the printed vase. Print it. We can print a vase directly with Z control at a rotating angle. Number 5. 100% waterproof water pump upgrade version. Non-contact magnetic coupling type. 2020 I have made a 100% waterproof water pump using a 3D printer. Now I modified it for better use and performance.
The concept is simple and clear. Separate the motor rotation part from the water injection part. If we seal the motor chamber completely, it is 100% waterproof. Use the magnetic coupling mechanism to transfer the motor torque to the impeller. I changed the connection part to screw type. It is much easier to fix them together. I also changed the motor shaft to a screw-fixed type. It will provide a very strong force to fix the shaft, and it is much easier to adjust the height of the rotation part to get the best position between magnetic coupling parts. I modified the motor chamber to a shorter stand and a long cap to cover the motor. It is also easier to fix the motor and maintenance. Now let's see how it will work.
It works very well. Number 4. Add CNC and other functions to normal 3D printer. Add more functions to 3D printers is a topic in my project. I have added a multi-pen plotter that can print color images easily. Now, I want to try adding a drag knife to 3D printer. Since I have no experience using a drag knife, I use conventional stuff for a test. It can work in a large area, but in a small area, it is not as good as I expected. I know one of the important reasons is the linear motion ball bearing is not smooth enough. I changed the long linear motion ball bearing to 2 alignment 2. Use ball plunger to restrict the whole base Z-axis movement. Now, construct them all together. Carefully adjust the contact of the ball plunger with the base. Now it is much smoother than last time. Let's check if it works or not. It is much better than last time. Even small text can be cut with a good precision. It looks like my effort is not waste. Let's test a thicker paper. The paper is similar to the magazine cover page. It works very nice. We can use it as a spray printing cover mask. The exoskeleton box that I added can be used very easily. When you want to change 3D printer to be a multi-pen color 2D plotter, you can attach this accessory easily. If you want to use it as a drag knife, just change the pen holder to a drag knife holder. All of them are no interference with the normal 3D printer function. We see that this attachment already added the CNC function to the 3D printer. Then, I add a PCB drill to change it to be a PCB drill machine. I use 20-degree 0.2mm V-shape engrave bit for the test. After opening the case, I have found the knife is really sharp and looks very nice. Since the copper cover layer of the PCB board is very thin, it usually has thickness less than 50 micrometer, say 0.05mm, so the mini DC 130 motor can do the job, I think. This motor can work as high as 12 volt, but usually about 5 volt is better. Make an attachment base and cover to fix the motor. Use this normal shaft to fix the PCB bit to the motor shaft. I suppose you don't want to make the 3D printer circumstance become a mess. I make this simple PCB box to fix the PCB board and contain the cutting waste. Now everything is prepared. Let's test how it works. This time it works very well. I have made the simplest and cheapest CNC drill bit in the world using office pin. It may not be used for a PCB drill, too soft for the copper layer. It can be used as a drill bit for soft board or PCB board itself. I have found the free software Carbide Create can generate the G-code much easier. I have even made a tutorial video that explained how to use Carbide Create. I have compared several normal drill bits for test. After adjusting some parameters, you can get a good CNC drill pattern. Then I try to use it to make a real badge using the end mill bit. I have found that only using one tool is not enough. I used a V-shaped drill bit and a 1mm end mill bit to do the job. The final result is still not perfect. I'm working on the road to be a professional, I think. Number 3. Reciprocating movement linear accessory that converts rotational motion to linear motion. I have checked the internet that how to convert rotational movement to linear movement. Usually, the linear movement direction is perpendicular to the motor shaft. This makes the whole accessory large. I use a simple and new design idea to change the rotational movement to a linear direction. The moving direction is parallel with the motor shaft. This will save a lot of space. It may be the first time in the world to change the rotation movement to a linear direction using this technique. After this new idea and concept has been published, I used this concept to design several accessories and made some modifications to make it easier to use. The outboard shaft has a common connection head. If we change the head to an office pin, this head will work as a simple tattoo machine. Please take care do not hurt yourself when you do a real tattoo experiment. If we change the head to a sanding block, this will work as a sanding pen. If we change to a sewing bit, it will work as a sewing machine. Number 2. First 3D printed straight one-way manual hand drill in the world. I have made a multi-thread screw that is very satisfying. It can even dance with the musical rhythm. How can we use this for daily life? Let's see how the normal screw and nut works. When push, it will rotate one cycle. When pulling back, it will rotate in the different direction. This is the normal way which normal bolt and nut works. Even this magic bolt and nut work the same way. Fortunately, this magic bolt can rotate in the same direction if we use another nut. We call them nut L, nut R respectively. L meaning rotate left hand or counterclockwise, R meaning rotate right hand clockwise. We will use these two nuts at the same time. Now the problem becomes how to make these two nuts rotate independently and keep the right direction. I add a surprise cage to make it happen. When we push the cage, the knobs on the bottom of nut L keep the upper nut fixed. The board will rotate clockwise direction. If the board is fixed, the nut will rotate counterclockwise. The nut R will rotate in a clockwise direction. When we pull the cage, the nut R will be fixed, and the board will keep the same direction, clockwise direction. The nut L will rotate clockwise direction. Back and forth, the board will keep the same rotated direction. If we reverse the direction of the cage, the rotated direction will change. It will keep rotation counterclockwise direction. The idea and the concept are explained clearly. Now we start to design the motor using Fusion 360. I have explained the detailed information in the video. You can know how to design the motor and how to get optimized parameters. One cycle push and pull, it will rotate about 6 cycles. It is very efficient. Let's fix the drill and try to make a hole on the wood board. Let's fix the drill and try to make a hole on the wood board. It is very easy and very fast. This manual hand drill works like an intelligent tool. Beautiful, efficient, powerful, and handy. It is the first 3D printed straight one-way manual hand drill in the world. After that, I also made some modifications to make it better use. Number 1. Handle part. I changed the handle part to a screw fixed part. It is easier and convenient to use. Number 2. Add a different drill size option. I added a different size of the drill which covered 0.8 to 4.0 mm. Number 3. Modify the leader at the stock coupling part. Enlarge the space between the small cylinder space. Now it is easier to couple them together between the cage and the nuts. Number 1. Useful tools made by 3D printer for DIY projects. Maybe I cannot say it is number 1 project because it is a collection of many small tools. These tools are simple but very useful in my opinion. 1. Automatic center punch. An automatic center punch is a hand tool used to produce a dimple in a workspace. Usually, they are made of metal. I designed a 3D printed version of this simple tool. It means that at that point it releases the force. Punch works very well. Here, I have a very easy but very effective tip for you. Use a smartphone as a guide tool. You will not need to use your own naked eye to find the punch point, or use some magnifying glass to get that point. Just adjust your smartphone in a good place using a simple tripod. You can magnify the place as well. And it will be much easier and effective than other devices. Two. Magnetic paper clip. It is simple to use to fix the papers with magnetic force. Three. A precision measuring electrode. It is useful when you want to measure at a very small place. 4. USB cover. Type A format. Still widely used, especially in the USB power supply. 5. Small tap holder. A small tap holder that fixes the small tap and makes it easier to use. It is very easy to make the thread using this small tool. 6. Precision mini drill press using DC-3 8A motor. DC-3 8A motor is a very good cost-effective DC motor, especially this sport-tuned type. It provides sufficient power for the plastic motor, wood, and light-duty metal hobby work. The speed can reach 24,900 RPM at 7.2 volt. The maximum torque is 129 gram-centimeter equal to 12.6 milliNewton-meter. The cost is really cheap. I use the sleeve bearing so it can move very smooth without shaking. I have used it very often and have found it is very useful and handy. If you have seen the video here, please do me a favor. Subscribe to my channel and click the small bell, so you will not miss an update. Tell me your channel is waiting for you.